Hello, welcome to Earth Science. We are going to be talking about extreme weather today. Let me get my screen shared with you and we will get started. All right, here we are. So starting off, how to find this, we're going to go into the modules, the current module that we're working in, and then you're going to go to today's date, whatever that might be for you in particular. The lesson's going to be the same regardless of what day you have it on. It will be different depending on whether you are in an even class, an odd class, or my virtual class. But it is the extreme weather lesson, so scroll down to that and then click the extreme weather page. You have a few things you're going to accomplish today. You're going to start off by completing a Bellwork assignment, very short, not time consuming. You're going to have notes, and then you're going to have a homework assignment. So let's take a look at the Bellwork first. Super short, quick, and easy. You are going to do some research on a type of extreme weather that you find interesting. You're going to find an example of that extreme weather. So pick a hurricane or a tornado or a hailstorm, some type of extreme weather that's happened. And you're going to tell me 2 facts about your example. So my example is Hurricane Isabel. My facts are it had winds up to 165 miles an hour, and it caused $3.6 billion in damage. That's billion with a B. For your example, you are not allowed to use Hurricane Isabel since I did, but any other example of extreme weather you can come up with is totally fine. Once you've posted, you'll put a reply to this post. Once you've done that, you'll be able to see your classmates' posts. Once a few of them have answered, you'll come back and you're going to reply to 2 of those. I prefer that you would pick classmates who chose a different type of weather. So if you picked a hurricane, choose somebody that talked about a flood or a dust storm or a hailstorm or something else. If hurricanes are the only thing up and that's what you chose, you can go ahead and reply to those if you need to. But try to reply to something that's a different type of extreme weather so you can have exposures to several of those and have some conversations. So your own post, reply to 2 others, and then you're done with the Bellwork. So you're going to come back to the lesson page. You're going to take notes, and you're going to do homework on extreme weather. Excuse me. This homework assignment is a quiz. It's not really a quiz. It's one of those that's set up as a quiz, but it really works because you can do unlimited attempts. So take it as many times as you need to get 100%, and you're good. As long as you get that done before the due date, you will get full credit. If you make further attempts after the due date, it will remove late credit from those future attempts, but it also will keep your highest score. So if you get a 9 out of 10 on an assignment before the due date, and then you get a 7 out of 10 after the due date, it's going to keep the 9. So when it comes time to do your homework, go ahead and click on this link to get you to the homework assignment. Take that quiz, do it as many times as you need to be happy with your score. It is also down here at the bottom of the page. So we've got the summary at the top, and then we have the actual lesson itself down here, Bellwork, notes, homework. So we're going to take a look at the notes now. Remember that anytime you are taking notes with me, you can pause the video, finish catching up on a slide, and then restart the video again when you're ready. You can also pause the video, take a break, and come back if you need to. It's completely up to you. We are going to go through these relatively steadily. So it is possible that you may need to actually pause the video in order to finish up before moving on to the next slide. I don't want the videos to be an hour long. So let's talk about extreme weather. What is it? Well, it's anything that's unexpected, unusual, severe, or unseasonal. So when we get snow in May, that's unseasonal. That would be extreme weather. If it's severe weather, we have massive hail, really, really strong thunderstorms, tornadoes. That's severe weather. If it's unusual weather, we have a hailstorm, but the hail is the size of a volleyball. Or if it's unexpected, so the weather just pops up without any notice or warning. Types of extreme weather. These are just a few examples. There are more examples out there of types of extreme weather, but some of the common ones are going to be cyclones. That includes hurricanes, typhoons, tornadoes. You can have heat waves, wildfires, dust storms, floods, cold waves, ice storms, hailstorms. We actually just experienced a cold wave about a month and a half or so ago here in the Midwest. We had one of those polar vortex systems drop down over the middle of the country, and we had temperatures that were down -22 to -28 degrees without considering wind factors. Once you consider the wind chill factor got down as low as -35 degrees Fahrenheit. So what is a cyclone? A cyclone is a large mass of spiraling air. All of that air circles around a central area of low pressure. That's what we call the eye of the storm. So it's a low pressure center. All of that wind going around it spirals in a direction that is determined based on what hemisphere it's in. If it's in the northern hemisphere, it's going to go counterclockwise. So that's all of us here in North America. If it's in the southern hemisphere, it's going to go clockwise. We've got a couple different types of cyclones. Hurricanes and tornadoes we're going to talk about in a little bit more detail. But basically a hurricane is going to happen over tropical water. We call them hurricanes here in the Americas. If you go over to the strip between Australia all the way up to Asia, including the Philippines and all of those Pacific islands there, it is called a typhoon in that area. It's the exact same type of storm, it's just where it's located. So hurricanes are over tropical waters. Tornadoes generally form over land, so over continents. Similar storms, but they don't require that warm water to fuel them. You can have minor cyclones. Dust devils are examples if there's no clouds, but the wind is picking up dust from the ground and swirling it around. You can also have a water cyclone, which is basically a tornado that forms over a large body of water like a lake. And it looks just like that, a tornado over the water. Polar vortex is what just happened to us with our extreme negative temperatures. And again, that's that Arctic air that normally hangs out above the Arctic Circle, dropping down into an area that it doesn't usually go. So here's a quick video of some cyclone damage. If your video player is not working here, I had to actually go to YouTube, watch a video, and come back in order to make this work. But I'm also including links here. So if your player doesn't work, this is the link to it in YouTube so you can watch it. So go ahead and pause me. Go take a look at this. It's kind of amazing, some of the damage that can be caused by this. It's about 4 minutes long. So take a look at that and then come back. All right, so tropical cyclones. Are they hurricanes or typhoons? If they're here at the North America, South America area, these are going to be hurricanes. Over here, Asia, all the way down through the Pacific Islands into Australia, those are typhoons. Same type of storm, same structure up here, but it's named based on what part of the world it's in. Remember, they all have that low pressure system in the middle and the swirling winds around it. The direction is going to change depending on whether it's northern or southern hemisphere. So facts about these, and they're the same regardless of whether it's a hurricane or a typhoon. They form over tropical regions. They get their energy from warm bodies of water. So once they leave the tropical waters, if they get up into colder waters, they're going to lose their fuel. They have no more gas. They're gonna die out. It's just like gas in a car, except the gas for the hurricane typhoon is the warm water. So once they run out of warm water, it's gonna weaken and die out. Same thing if it goes over land. Once a hurricane hits land, it's going to diminish its power significantly because, again, it's not sucking up that warm water into it from the tropical oceans, so it's losing its fuel. So tornadoes. Tornadoes are going to happen over land masses on the continents. So if you get one over a lake, it's called a water cyclone. Most tornadoes are going to happen over land masses like this. There's a quick video here from National Geographic that's a couple minutes long. So take a look at that, and then we will come back and talk about cyclones. Okay, we have two types of cyclones, supercells and non-supercells. If you have multiple storms that kind of collide and join together to form one massive storm, that's going to be a supercell. Non-supercell is an individual isolated storm. We have a lot of these here in the Midwest. Here's some about the UK cases. They generally have about 88 cases a year. However, they have a much smaller area of land, so their 88 cases make that the highest density area where they occur. The highest number or intensity is generally here in the United States. We have about 1,000 cases a year, and we can get some that are Category 5, pretty severe storms. So circulating winds all around the low pressure center in the middle. We live in Tornado Alley here in Missouri, Kansas. It stretches all the way from Texas to Canada. And it's the area where tornadoes are most likely to happen because you get a lot of these supercells, a lot of storms that meet up, and a lot of this violent collisions of storm fronts causing the damaging winds. Heat waves and wildfires. A heat wave is basically any unusually hot temperatures for an extremely long time. So they generally, if you have a heat wave, you don't get a lot of rain. You can get drought conditions. You get really high temperatures for very long times. You have a high pressure in the upper atmosphere that basically traps the heat down here in the lower atmosphere, and it keeps it here. Not a lot of air movement going on during heat waves. You can get droughts. You can have vegetation start not getting enough moisture to be able to survive, so it dies off, dries out. That can then lead to wildfires. A wildfire is just what it sounds like, a fire out in the wilderness. It can be started by lightning strikes. It can be started by people. If you're driving by and you flick your cigarette out the window and you've got dry, brittle vegetation, that can start a wildfire. Please be mindful of that and don't do it. These are super dangerous. If they start encroaching on areas that are inhabited by people, they start getting close to cities, towns, then you have firefighters having to put their lives on the line trying to put out these fires. And that's not an easy thing to do. We lose firemen every year battling these types of wildfires. And a lot of them are started because of irresponsible people driving through. All right, so here's a video on wildfires. If you're not able to see this with your notes that you're looking at, there will be a link over here. I will get that put in for you so you can link directly to the YouTube video. Pause me, take a look at this video, and then come back. Dust storms and sandstorms, again, just what it sounds like. You have areas that are very, very dry. So you have a drought happening, or it's a desert area anyway, and you get really strong winds through those areas. That's going to blow up walls of dirt and sand. This is an actual image of a sandstorm over here on the right. It causes damage to vehicles, buildings. It can bring in, tons and tons and tons of sand and bury things. It can make it hard to breathe. You don't want to get caught in this. You can't see where you're going. You can't breathe through this because you breathe in all of that dust. It can sandblast materials like metal, wood, concrete, cause them to become weaker, cause them to collapse. So these are really big deal, and you want to stay out of these. If you have a sandstorm coming, you need to take cover immediately. We generally don't get them in our area unless you're kind of out in the middle of nowhere and we've had an extreme drought for a long time. Cold waves, ice storms, blizzards. We had, you experienced that cold snap in February. We've had ice storms in the past with, grapefruit-sized hail, volleyball-sized hail, blizzards. We've had several of those where there's been whiteout conditions, you haven't been able to drive. We've gotten feet of snow. It doesn't happen very often here in the Midwest, but when I lived in New York, we regularly got feet of snow at a time. These types of extreme weathers can be referred to as cold snaps or cold spells, a cold wave. There's lots of different causes for these. One of the causes, especially for the recent one we have, is again that polar vortex coming down. But you can have all kinds of different conditions that will arise that will cause these to happen. If we get these cold snaps after spring, when plants and flowers and trees have started to bloom out already, it can actually damage those and cause them to not bloom as well, not grow as well for the season. Ice storms can cause breakage of structures and plant matter of trees, those kinds of things. If the ice on them is too heavy, it can cause them to break or fall over. Hailstorms, very similar. You're going to get the hail. It's like a little ball of ice. And again, they're typically smaller than pea size. However, you can get large hail up to basketball size, depending on how long it spends in the cloud, how many cycles it goes through of the rise and fall. We talked about this a little bit in the last unit. We talked about clouds and how these hailstones form. Cold downdraft drops the heavy ice. It melts a little bit. Warm updraft causes it to freeze again. And that cycle down and up makes it get larger and larger. And then this is a video of a beach over in Siberia where they had a sudden hailstorm hit. They were all out there on the beach in the summertime enjoying a nice warm front, warm weather, clear, perfect day at the beach. And then all of a sudden, boom, hail. So kind of an interesting video to watch. If you can't see it, go ahead and click the link here. And then once you are done with this video, go ahead and switch over to your homework and you will be done for the day. We'll see you next time.